There are moments in astronomy when the universe seems to remind us just how small our understanding really is. We look into the darkness with powerful telescopes, map distant stars, study enormous planets, and build theories about how worlds are born. Yet every time we think we are beginning to understand the cosmos, something appears that challenges what we thought was possible. Now imagine discovering a world larger than Jupiter, floating hundreds or even thousands of light years away, so enormous that its very existence forces scientists to ask uncomfortable questions about how planets can form and survive. Jupiter has always been the giant of our solar system. It is more than 11 times wider than Earth and contains more than twice the mass of all the other planets combined. For generations, it has represented the upper limit of what a planet could look like in our own cosmic neighborhood. But beyond the Sun, the universe contains worlds that make Jupiter seem almost ordinary. The discovery of an enormous exoplanet is not simply about finding something big. It is about understanding how nature builds worlds. Some giant exoplanets orbit their stars at distances where scientists once expected planet formation to be difficult. Others exist around stars whose environments appear completely different from our own solar system. And some are so unusual that researchers must reconsider the boundary between planets and brown dwarfs. Objects that are too massive to be ordinary planets, but not massive enough to ignite sustained hydrogen fusion like true stars. This is where the mystery becomes truly fascinating. When astronomers detect a giant planet, they do not simply take a photograph and measure its size. Often, they discover it indirectly. A planet can reveal itself when it repeatedly passes in front of its star, causing a tiny dip in the star's brightness. Another technique measures the subtle gravitational movement of the star as the planet pulls on it. Some giant planets are enormous, but surprisingly lightweight. Their atmospheres may be extremely inflated, possibly because they orbit very close to their stars and receive tremendous amounts of energy. In these cases, the planet can become swollen, expanding far beyond what its mass alone might suggest. Other massive worlds may be dense, compact, and rich in heavy elements. Two planets can appear similarly enormous while having completely different interiors. One could have a relatively small core surrounded by a vast atmosphere. Another might contain a much heavier interior beneath its gaseous envelope. That means the discovery of a planet larger than Jupiter is only the beginning. The real scientific treasure lies beneath the surface we cannot see. What is inside this world? What chemicals fill its atmosphere? Does it contain clouds made from exotic compounds? Could powerful winds race around its atmosphere at thousands of kilometers per hour? Does its enormous size come from extreme heat, unusual chemistry, or an extraordinary formation history? Modern space telescopes are beginning to answer some of these questions. Instead of merely detecting distant worlds, astronomers can study the light passing through their atmospheres. Molecules leave distinctive fingerprints in that light. By analyzing those patterns, scientists can search for water vapor, carbon dioxide, methane, and other compounds. For a giant exoplanet, the atmosphere may be a gigantic laboratory. A world larger than Jupiter may have atmospheric conditions completely unlike anything found on Earth. And this is perhaps the most exciting part of the discovery. The universe does not appear to have followed a single blueprint. Our solar system contains rocky planets, gas giants, icy worlds, dwarf planets, moons, asteroids, and comets. But when astronomers began discovering planets around other stars, they encountered something unexpected. Hot Jupiters, super-Earths, mini-Neptunes, a giant world beyond Jupiter. The discovery of an exoplanet larger than Jupiter challenges our understanding of how massive planets can become. For generations, Jupiter has stood as the giant of our solar system, an enormous world surrounded by dozens of moons and powerful storms. But when astronomers look beyond our solar system, they continue to discover planets that challenge even this familiar standard. The detection of an exoplanet larger than Jupiter immediately raises one of the most fascinating questions in modern astronomy. How can a planet become so enormous? A giant exoplanet is not simply a larger version of Earth. Most of these worlds are dominated by hydrogen and helium, with enormous atmospheres surrounding deeper layers of compressed material. Some can reach several times Jupiter's radius or mass, although scientists must carefully distinguish truly massive planets from brown dwarfs, which occupy a fascinating boundary between planets and stars. The discovery of an exceptionally large world can provide important clues about planetary systems far beyond our own. It may reveal that planets can gather enormous quantities of gas under conditions that were once considered unusual or difficult. In some systems, giant planets may form far from their stars and later migrate inward. Others may develop through rapid accumulation of material, while their young star is still surrounded by a dense disk of gas and dust. What makes these discoveries especially exciting is that size alone does not explain a planet's nature. Scientists must examine its mass, density, temperature, orbit, and atmosphere to understand its true identity. A world larger than Jupiter, therefore, represents more than an astronomical curiosity. It is another reminder that nature can create worlds in ways that continue to surprise us, expanding our understanding of what a planet can actually be. The mystery of planet formation. Scientists must investigate how such enormous worlds formed, whether through rapid gas accumulation, core growth, or processes closer to star formation. The discovery of an enormous planet beyond our solar system raises an even deeper mystery. How did such a massive world form in the first place? Planet formation is a complex process that begins inside a young star system, where enormous disks of gas and dust swirl around a newly forming star. Tiny particles collide, gather together, and gradually create larger bodies. Over time, gravity takes control, pulling more material toward growing planetary cores. For a giant planet to become truly enormous, it must capture vast quantities of gas before the surrounding material disappears. Scientists believe that some gas giants begin with a solid core that becomes massive enough to attract hydrogen and helium from the surrounding disk. Under the right conditions, this process can accelerate dramatically, allowing the planet to grow to extraordinary proportions. However, exceptionally massive planets challenge this simple explanation. If a planet becomes too massive, scientists begin asking whether it truly formed like a planet or through a process more similar to the formation of a star. This creates an intriguing boundary between giant planets and brown dwarfs, objects that are more massive than typical planets, but not massive enough to sustain ordinary hydrogen fusion. Another possibility involves planetary migration. A giant planet might form farther away from its star, where there is more material available, and then gradually move inward. As it travels, gravitational interactions with the surrounding disk or other planets can alter its orbit. Every enormous exoplanet, therefore, becomes a natural experiment. By studying its mass, orbit, age, and chemical composition, astronomers can reconstruct pieces of its origin story and determine which formation process could have created such. Size doesn't tell the whole story. Giant planets can have very different densities and interiors, with some becoming extremely inflated because of intense heat from their stars. When astronomers discover a planet larger than Jupiter, one of the first assumptions people might make is that a bigger planet must also be much heavier. But the universe is not always that simple. Some giant exoplanets can be enormous in size while having surprisingly low densities. Their huge dimensions may come from atmospheres that have expanded dramatically under extreme conditions, rather than from an enormous amount of additional material. One important factor is heat. If a giant planet orbits extremely close to its parent star, it can receive tremendous amounts of radiation. This intense energy can heat the upper atmosphere and cause the planet's outer layers to expand. Scientists sometimes describe these worlds as inflated planets because their physical size can become much larger than expected for their mass. Other giant planets may be compact and extremely dense. Their interiors could contain substantial amounts of heavier elements beneath thick layers of hydrogen and helium. Two planets with similar radii could therefore have completely different internal structures and histories. Understanding this difference requires more than measuring a planet's diameter. Astronomers need to determine its mass as well. By combining mass and radius, researchers can estimate the planet's average density and begin developing models of its interior. Temperature, distance from the star, age, and atmospheric composition can provide additional clues. A young planet may still be releasing heat left over from its formation, while an older planet may have contracted over billions of years. This makes every giant exoplanet a fascinating puzzle. Its size is only the first clue. Beneath the enormous atmosphere may be a compact interior, a massive core, or an unusual mixture of materials. Alien atmospheres hold the answers. Advanced telescopes can analyze light from distant planets to identify atmospheric chemicals and reveal clues about their composition and history. One of the most powerful ways scientists can investigate a distant giant exoplanet is by studying its atmosphere. Even when a planet is hundreds or thousands of light years away, the light passing through or reflecting from its atmosphere can reveal remarkable information about what exists there. Modern space telescopes have made it possible to examine these faint signals with increasing precision. When a planet passes in front of its star, some of the starlight travels through the planet's atmosphere before reaching our telescopes. Different molecules absorb specific wavelengths of light, creating patterns that scientists can analyze. These patterns can provide clues about gases such as water vapor, carbon dioxide, methane, and other chemical compounds. For a planet larger than Jupiter, the atmosphere could be especially interesting. Its enormous size may produce powerful atmospheric circulation, extreme temperatures, and unusual cloud formations. If the planet orbits very close to its star, one side could experience intense radiation while the opposite side remains comparatively cooler. This temperature difference could generate extraordinary winds across the atmosphere. Scientists can also study how a giant planet changes over time. If its atmosphere is expanding, escaping into space, or reacting with intense stellar radiation, those processes can reveal information about the planet's history. The atmosphere may even provide clues about how the planet formed. Certain chemical compositions can suggest whether a world developed close to its star, formed farther away, or migrated inward during its evolution. What makes this remarkable is that scientists do not need to physically visit the planet. They can study its distant light and extract information hidden within it. A feint. The universe is stranger than our solar system. Giant exoplanets demonstrate that planetary systems can be radically different from ours, reminding us that our solar system may be only one possibility among countless cosmic arrangements. The discovery of a world larger than Jupiter is not just a story about one enormous planet. It represents something much bigger, a growing realization that our solar system may be only one example of how nature can build planetary systems. For a long time, scientists naturally studied the Sun, Earth, Jupiter, and the other planets as the primary examples available to us. But thousands of exoplanet discoveries have revealed a universe filled with possibilities that are far stranger than our familiar neighborhood. Some planetary systems contain giant worlds orbiting incredibly close to their stars. Others have planets traveling along unusual orbital paths or multiple worlds packed tightly together. There are planets that appear extremely hot, worlds surrounded by enormous atmospheres, and objects whose properties blur the traditional boundary between planets and brown dwarfs. A giant exoplanet, therefore, becomes another piece of evidence that planetary formation does not follow one simple recipe. The conditions around different stars can produce dramatically different outcomes. The amount of gas and dust available, the star's chemical composition, gravitational interactions, planetary migration, and the age of the system can all influence what eventually develops. This is why discoveries involving enormous planets are scientifically valuable. They give astronomers opportunities to test existing theories and identify where those theories may need improvement. If a planet is larger or more massive than models predict, researchers must investigate what process could have produced it. The most exciting possibility is that this discovery may not be an exception at all. It could be a sign that many unusual worlds remain hidden and distant.